Hi everybody, you are watching Summer Review video number 4, Operations with Polynomials. A polynomial in the variable of x is an expression of this form here. Now, I don't want you to, get too scared off by this, but this is just a fancy way of writing a polynomial in general. Well, what do we see here? We see a sub n times x raised to the n. Plus a sub n minus 1 times x to the n minus 1, plus dot, 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 meaning this is going to keep going all the way down to a sub 1 x to the first plus a sub 0. All right, well, what are all the a's? Well, first of all, the a sub n is not allowed to be equal to 0, all right? And then the polynomial is going to be degree n, all right? So that means that our polynomial is degree n, that's the highest power that we saw, so that's the degree, all right, and the leading coefficient is going to be your a sub n. A sub n is the leading coefficient, and a sub 0 here is going to be the constant term. So this is our constant here. All right, it's the term without a variable in it. All right, so let's take a look at some terminology. A polynomial with one term is called a monomial. So for example, something like 7x to the 4, that would be an example of a monomial. 3, that would be an example of a monomial. W, that would be an example of a monomial, just one term. If you got two terms, it would be a binomial. So for example, something like 6 plus 3y, that would be an example of a binomial. Or 8x cubed plus 9y. That would be an example of a binomial, two terms. If you have three terms, that's known as a trinomial. So that, for example, might be something like 4x to the 6th minus 3x plus 1. That would be an example of a trinomial. Now, if we put a polynomial in standard form, that means that the powers are descending. All right, so for example, if I had something that looked like 4x minus 5x squared plus 9, that's not in standard form because the powers, which would be 1, 2, and really this is x to the 0, those powers are not descending. So if I wanted to write it in standard form, I would have to write it with the highest power first. That would be the x squared term. And the coefficient on that was a negative 5. So I'd have to write negative 5x squared plus 4x plus 9. That's my polynomial written in standard form because now the powers are descending. So it goes 2, 1, and 0 because that would really be 9x to the 0. All right, the degree of the polynomial is the highest degree of its terms. The leading coefficient of the polynomial is the coefficient of the highest degree term. So let's take a look at this example. It says write in standard form and then state the degree of the polynomial and state the leading coefficient. So in this case, it's not in standard form because the degrees are not dropping down. Here's our highest degree, here's our next highest degree, and this is really x to the 0, so that would be our lowest degree. So to put it in standard form, we would have to write it as 3x to the 7th minus 8x to the 5th plus 2. In this case, we're asked to identify the degree. Well, the degree is going to be this highest power that we see, so it's going to be degree 7. And the leading coefficient is going to be the number on that same term with the highest. So our leading coefficient is going to be equal to 3. All right, to add or subtract polynomials, you need to add or subtract the like terms. Like terms have the same variables raised to the same powers. So in this case, if we are adding these two polynomials together, I see an 8x here, and do I have any other x's? Yes, I've got a negative 2x, and I'm adding, so I need to do 8x plus a negative 2x, which would give me 6x. All right, what about x squared? I see an x squared term here and I see an x squared term here, and again I'm adding, right, here, so I'm going to take a negative 3x squared plus a negative 4x squared, I'll say it that way, which would be a negative 7x squared. And then do I have constants? Well, sure, I've got a 6 here, and I've got a 7 here, and I am adding those, so that's going to give me 14. So I'm really adding these three together, 6x plus a negative 7x squared plus 14, but let's put it in standard form, and slide this down a little bit. And so we get, negative 7x squared plus 6x plus 14 as our answer, written in standard form. All right, let's take a look at this example. Now this one is an example of subtracting. So for this example, when we're subtracting, I would remind you that subtracting is the same thing as adding the opposite. But if I've got a negative out in front of this, since I'm adding the opposite, that's the same as making each of these inside negative. So in other words, I can write 5x cubed minus 7x plus 5x squared plus 9, but then I'm adding on a negative 4x squared, a minus 6x cubed, minus a negative is plus a positive, so I get plus 5x, and minus a negative 1 is going to be plus 1. So I changed this problem to addition, but then I had to change the signs of everything in the second parentheses. And now it's a can you match them up and add them up game. So I've got 5x to the third here and a negative 6x cubed here. That's going to give me a negative 1x cubed. My next highest term is x squared. I've got a 5x squared here and a negative 4x squared here, which would be a plus 1x squared. 1 is optional. You don't have to write it in, but it's understood to be a 1. All right, then the next would be the x terms. I've got negative 7x here and a 5x here, and I am adding, so that's going to be a minus 2x. And then lastly, I have a constants. I've got a plus 9 and a plus 1, and so I get plus 10. And that should be my answer for this problem. All right, let's take a look at some examples of multiplying. If I want to multiply a binomial times a binomial, the best way to do that would be to use FOIL. All right, if you're familiar with that term, that means first, outer, inner, and last. So if I'm going to multiply this using FOIL, I'm going to multiply the first terms together. 3x times 5x is 15x squared. Outer terms would be 3x times 2 is 6x. Inner terms would be 7 times 5x is 35x. And my last terms would be 7 times 2 is 14. I'm going to combine any like terms that I have, and I do have some. So I'm going to have 15x squared plus 41x plus 14 as my answer. All right, let's take a look at this example, 5x squared minus 3 times 7x plus 2. And so for this one, again, I want to multiply using FOIL. So first terms would be 35x cubed. Outer terms would be a 10x squared. Inner terms would be a minus 21x. And last terms would be negative 3 times 2 is a negative 6. I don't have any like terms to combine. I have it already in standard form. The powers are decreasing, so I think it looks like it's good. All right, so let's talk about special products for a moment. Special products can help you multiply a little faster if you know the product. For example, if you have something of the form u plus v times u minus v, that's the same as u squared minus v squared. So in this case, I could multiply this all out using FOIL, first, outer, inner, last, but when I do, the uv plus the negative uv are going to subtract off, and I'm just going to be left with u squared minus v squared. All right? And so a little example of this would be if I had something like, let's say, 5x plus 3 times 5x minus when I multiply these together, if I use this special form that I don't even have to do FOIL, because I notice I've got, this is like my U here, right, those match, and then this is like the V here, right, and so then my product would be just U squared minus V squared, all right, and so I get 25x squared minus 9, and I did not have to do FOIL to get that answer. Okay, so let's take a look at this next example. This next example is another special product pattern, and this one says if you have U plus V quantity squared, like this, that's the same thing. You could write it out as U plus V times U plus V, because remember, that's what this is saying. It's saying you got a binomial and you're squaring it. So you're going to take that binomial and multiply it by itself. So at this point, you could use FOIL, first, outer, inner, last, or you could just go to U squared plus 2UV plus V squared. All right, and likewise, we have another similar pattern that says U minus V quantity squared. So if you have a U minus V quantity squared, that's the same thing as saying U minus V times U minus V. Let me fix this up here. U minus V, U minus V, and then my pattern is going to be U squared minus 2UV plus V squared. Notice that these two formulas only differ in this one sign right here. Otherwise, they're exactly the same. So let's take a look at this first example. Find the special product. So 4x minus 3 quantity squared. So again, you could use FOIL and write 4x minus 3 times 4x minus 3, but instead of that, we could use our special product property, which says 4x is my U and 3 is my V. And so my property says U squared minus 2UV plus V squared. So I'm going to fill in my U, which was 4x, quantity squared, minus 2 times 4x times 3, plus my V squared. Remember, V is 3, U is equal to 4x in this example, and V is equal to 3, so plus 3 squared. And so my final answer would be, if I'm simplifying this, I would have 16x squared. 2 times 3 times 4 is, what, 24, so I have minus 24x plus 9. All right, let's try one more of these examples. For this one, I have 9x plus 2y quantity squared. Again, I could use FOIL and do 9x plus 2y times another 9x plus 2y and do first, outer, inner, last. But let's try and use the pattern that we are given. So in this case, I notice that it's a U plus V quantity squared pattern, where 9x is my U and 2y is my V. So we get some more shrinking this one down here, and let's get our formula going. So if I have this, slide that down, slide that down. So if I am matching this up, I know that my pattern is U squared plus 2UV plus V squared. And if my U is equal to 9x and my V is equal to 2y, I'm just substituting those in. So I'm going to write 9x quantity squared, that's my U squared part. That's supposed to look like a U. And then I want plus 2 times U, which is 9x, times V, which is 2y, plus V squared is 2y quantity squared. Notice how careful I am. I'm putting parentheses around my 9x before I square it. I'm putting parentheses around my 2y before I square it. So now when I simplify, 9x quantity squared means the 9 has to be squared and the x has to be squared. So I'm going to have 81x squared. Here I've got 2 times 9 is 18, times 2 is 36, so I get plus 36x y. And then here I have 2y times 2y, which would be 4y. y squared. So that would be my answer here. Okay, so that okay, so that brings up our additional practice problems. There are 4 of them for you to try. I would pause this video, try these problems on paper, and then go on to check your answers on the next page. And hopefully you will feel confident enough to be successful on the quiz where there are 5 questions. And again, you need to get 4 out of the 5 correct. So go ahead and pause this video if you have not already. Okay, hopefully you had a chance to practice these problems. Here are the solutions. All right, and if you did not get these or you got some question about them, look back, and if you really can't figure out what's going on, then please let me know. So here are your, here's my email address in case you need to contact me about some error that I've made in the video or a problem on the quizzes. All right, thanks for watching and have a great day.